Good morning, everybody. My name is Dr. L. Lakshmi Prasanna Kumar, Assistant Professor, Electronics and Communication Engineering Department, G. Polarity Engineering College, Autonomous Kurnool. Welcome to the lecture series of Electronic Circuit Analysis. The last lecture, we discussed about the importance of the H parameters and how we have to define the internal structure of the transistor by using H parameters and why it is called as a H parameters. If you want to convert any practical circuit into AC equivalent model, what are the conditions we require? These are all the things what we are coming across in the previous lecture. In the today discussion, we will concentrate relation between the H parameters and parameters of the amplifier. That is, relation between the H parameters and parameters of the amplifier. As we know that parameters of the amplifier is very important for a communication engineer to design any effective communication system. The parameters of the amplifier are nothing but voltage gain, current gain, input resistance and output resistance. First, initially we will try to relate the H parameters with respect to the parameters of the amplifier of a single stage, that too low frequency. Here we are concentrating of low frequency amplifiers of single stage. After that, we will try to extend this analysis to the multi-stage. Then we can understand easily about that if you want to design any practical amplifier, why we have to concentrate on multi-stage. Single stages are not applicable in major crucial application of a communication system. Even if you consider inside the mobiles and in base stations, in satellites, or any other application which is related to the communication, we are expecting more applications from the multi-stage rather than single stage, where in a wireless environment, as the signal is propagating, it undergoes number of losses. To recover that signal at the receiver, we are using the concept as de-emphasis. Of course, we are using the same concept at the transmitter side known as pre-emphasis. Nothing but increasing the amplitude of the signal. That is the first stage what we have to consider. We want to use the signal for a practical application and further proceedings inside the communication system. So that's why the amplifier is very crucial, especially on the pre-emphasis and de-emphasis. There are single stages we can't achieve. Why? Because the amplitude of the signal already degraded with the wireless environment, which undergoes number of losses like fading, diffraction, scattering. Man-made environment and human-made environment are highly influencing on the amplitude, phase, and delays. So that obviously the signal corrupted and obviously it undergoes number of losses. In order to recover that, we require the multi-stage. That's why we will try to extend our analysis from single stage to multi-stage, that to low frequency amplifier. So initially I am concentrating once again the two parametric H parameter equation of a transistor, where VBE is equal to HIE IB plus HRE VCE, IC is equal to HFE IB plus HOE VCE. So these are the two prominent equations already we are coming across in the previous lecture. From this, we'll try to derive the voltage gain, current gain, input and the output resistance. So initially, I am concentrating current gain. Current gain is defined as AI. So, as we know that the general definition of any gain is nothing but output by input. Output by input. So we are concentrating on current gain. It is a ratio of output current by input current. Starting from the analysis of H parameters as well as the parameters of the amplifier, among three configurations in every aspect, even the H parameter transistor equations also, I am considering common emitter configuration only. So that in common emitter configuration, the output current is nothing but IC. Of course, input current is IB, or with respect to AC equivalent model, output current is IC. This is the input current is I. This will explain the DC values and this will explain the AC values. That is a current gain. Gain is defined as A and we are using the current gain. That's why it is in the suffix I am representing with a capital letter AI. So that finally AI is equal to IC by I. This is a general formula of current gain. It is a ratio of output current by input current. Now we have to extract this current gain with respect to H parameter. For that purpose, I am considering the second equation. So once again, I am trying to highlight the second equation. IC is equal to HFV into IB plus HOE into VCE. I am considering this equation. As we know that the AC equivalent model of a transistor consisting of 4 parameters: HIE, HRE, VCE. Of course, this is IB, where I am using common emitter configuration. This is HFV, IB, and this is HOE, where this is IC. If any external input resistance is there, that is defined as RS. Any external output load is there, that is defined as RL. And the input source as VS. Now, if you carefully observe here, this is input current as VBE, and this is IL. Now, as we know that the output is taken across the collector, input is applied across the base, and the emitter is common. The output voltage is nothing but VCE or V0. In this common emitter configuration, V0 is nothing but VCE. By seeing the equivalent model, we can easily analyze that. And VCE is nothing but whatever the current flowing across RL is nothing but VC. So that VCE is equal to IL into RL. And if you carefully observe at this node of collector, IL current is going through the resistor and IC current is trying to divide. IC current is moving outside and IL current is moving outside. Both are in opposite direction. I can conclude IL is equal to minus IC. I am representing the load current in the form of collector current. Both are in moving away from the node. That's why IL is equal to minus IC. So I can represent the IL in the form of IC so that I can consider VC is equal to minus IC into RL. So this is the thing what I am getting from the AC equivalent model at the output side. Now I am trying to substitute this. I am considering as basic equation. Here I am considering as it is second equation, what I am coming across in the two equations of H parameter equations which are related with the transistor, and this I am considering as equation 3. Substituting equation 3 in equation 2. So I am substituting equation 3 in equation 2. After substituting the resultant equation of equation 2, IC is equal to HFV IB plus HOE. In the place of VC, I have to substitute third equation minus IC into RL. This as equation 4. Now IC is equal to HFV IB minus HOE IC into RL. I am trying to equate all IC terms on one side and IB terms on another side, so that I am trying to send this term on LHS. Then the final equation will become as IC of 1 plus HOE into RL, 1 plus HOE into RL equal to HFE into IB. That is equal to HFE into IB. So now, as we know that from the basic definition of current gain, output current by input current, then this is output current by input current. IC is equal to IC by IB is equal to HFE by 1 plus HOE into RL. So this is the IC by IB. But according to the definition of a current gain, as we know that minus IC by IB, in the previous slide, what already we are coming across the basic definition. This is, here we have to indicate the minus sign. Why we have to represent the minus sign, I will try to come across. In two ways we can say. As we know that IL is equal to minus IC. And here also we have to consider AI is equal to minus IC by IB. Why? Because always input current and output current both are superimposing. For example, you consider this is the common emitter configuration. This is emitter, base, and collector. The input current is base and the output current is collector. Both are in opposite direction. So we are getting a phase shift of 180 degrees. This already we are coming across in previous lecture about the importance of H parameters. Once again, I am trying to remind that the input current and output current both are in opposite direction. To represent that, we are getting minus IC. This is, one is a positive phase and the output we are getting as a negative. If you are applying the negative and the output is getting as positive, a phase shift of 180 degrees we can experience from this internal operation of the transistor, which is operated in common emitter configuration. So the current gain is minus IC by IB. Generally, gain is nothing but output current by input current. Here the output current we are getting in out of phase. That's why, according to the definition, AI is nothing but minus IC by IB. And substituting this IC by IB here, then finally AI we are getting as minus HFE by 1 plus HOE into RL. So even we can represent in the two ways how we are getting the negative sign here. And here also we can represent that actually the output current is IL and the input current is IB. I am representing IL in the form of IC so that I can consider it as minus IC by IB. In that way also we can explain. So two ways I am trying to convey that how we are getting the negative sign here. The current gain is minus IC by IB. Why? Because I am representing the load current in the form of IC current. From the, according to the AC equivalent model, IL and IC both are in opposite direction. That's why IL is equal to minus IC. So if you frame it the same thing in the definition, we are getting AI is equal to minus IB by IB. Of course, minus IC by IB. That is one way. The another thing is input current and output current both are in out of phase. That's why also we are getting as output current in out of phase of minus IC. So that finally I am considering AI is equal to minus HFE by 1 plus HOE into RL. Here the AI is the parameter of the amplifier. I am representing with respect to the H parameter. This is the thing what we have to analyze, that if you don't know the knowledge of HFE and HOE, it's very difficult for us to find out the current gain of the amplifier. The next parameter is input resistance. Input resistance or impedance. Input resistance or impedance. From the transistor H parameter equation, we know that input voltage VBE is equal to HIE IP plus HRE VCE. So this is the equation 1, what I am considering. As we know that from the basic definition of input resistance, RI is equal to, input resistance is a ratio of input voltage VI by I input. So in this case, VI is nothing but VBE and the input current is nothing but I. If you get the relation in the form of voltage and current, that to input voltage and input current, then obviously we can easily find out the input resistance of the amplifier. In the first equation, I am considering, as we know that from AI, VCE is equal to minus IC into this, already we know that. VCE is equal to minus IC into RL from AC equivalent model of a transistor. From AC equivalent model of a transistor. So that substitute VCE in the above equation, you are getting as VPE is equal to HIE into IB minus HRE IC into RL. From current gain, we know that minus IC by IB. Just now we defined this. So in the place of minus IC, I can consider it as AI into IB. So that we have to substitute this IC in the above equation. Then VBE is equal to HIE into IB plus AI IB into HRE into R. So after substituting this minus IC value in the above equation, we are getting this resultant equation. Now I am trying to take IB as common so that IB equal to HIE plus AI into RL. Same thing I am trying to convey. VBE is equal to IB into HIE plus AI into RL. HIE plus HRE is missing. HRE AI into RL. And I am taking the ratio by sending this IB to LHS. HIE plus HRE AI into RL. This is nothing but input resistance or input impedance of a transistor of an amplifier. HIE, HRE, AI into. This is one more parameter of the amplifier I defined that I am representing with respect to the H parameter. So unless until you don't know the knowledge of HIE and HRE, it's very difficult for us to find out the input resistance of an amplifier. The next parameter is voltage gain. Voltage gain is defined as AV. Just now what I defined that the gain is nothing but output by input. We are concentrating voltage gain. In the suffix we are using the V as a letter we are using indirectly. It is telling that it is voltage gain. So voltage gain is defined as output voltage by input voltage. But from the AC equivalent model, output voltage is nothing but VCE. Input voltage is nothing but VBE. The ratio of output voltage and input voltage will give us the voltage gain of the amplifier. As we know that VCE is defined as VCE is equal to minus IC into RL. That already we know that. So I am trying to substitute this VCE value here so that I can consider VCE as, I am substituting this VCE value in the above equation. First I am writing voltage gain is nothing but VCE by VBE, and you try to substitute that value here and it is getting as minus IC into RL by VB. Now you concentrate. AB is nothing but minus IC into RL by VBE. As we know that AI is equal to minus IC by IB. This already we know that minus IC is equal to AI into IB. In the place of minus IC, I can consider it as AI into IB into RL by VBE. Of course, we can send this minus sign to here also, so that it is becoming as minus AI into IB into RL by VBE. This I can consider it as AI into RL by VBE by IB. This is nothing but minus AI into RL by R input. That is nothing but A. So where in the denominator R input is nothing but input resistance, The numerator AI is nothing but current gain. So if you have the knowledge of current gain as well as input resistance, we can easily find out the voltage gain. And if you want to get the knowledge of current gain and input resistance, we require the knowledge of HIE, HFE, HRE, and HO. This is the interlink between the parameters of the transistor and the parameters of the amplifier. The next parameter will consider it as output resistance or output impedance. Output resistance or output impedance. Which is defined as R naught. So R naught is nothing but output resistance. It is a ratio of output voltage by output current. Output voltage is VCE. Output current is IC. If you find the ratio between these two, obviously we can find out the output resistance. As you know that from the H parameter equations, I am considering the H parameter equation as VBE is equal to, or directly I will try to substitute as IC value directly here. So IC is equal to, as you know that HFE into IB plus HRE into VCE. Now I am trying to substitute this value. R naught is equal to VCE. Substituting this IC value here. HFE into IB plus HRE into VCE. Now from the AC equivalent model, once again I am trying to modify or simplify this R naught. It is not completed. I am just trying to highlight here. Once again I am trying to draw the AC equivalent model. As we know that HIE, HRE, VCE, HIE, this is IB, and the source resistance which is connected. And the source is connected, yes. And in the output side, as we know that HFE into IB, HOE, so external load resistance. Okay. If you want to find out the output resistance of the amplifier, I have to apply one condition that where input must be short circuited. Input is short circuited where Vs is equal to 0 and exclude RL where R naught is equal to infinite. So these are the two conditions what we have to apply in order to find out completely about the output resistance of the amplifier. So for that purpose, after applying Vs is equal to 0 and excluding the RL, applying the KVL at the input side, the resultant equation will be, so Vs is equal to 0 and exclude RL. By considering these two conditions and applying KVL at input side, so Vs is equal to 0 minus, of course, HIE, sorry. So here the input current is coming, so where IB into RS, HIE into IB, so plus 2 minus, plus 2 minus, plus 2 minus, and this is almost all short circuited where Vs is equal to 0. From this equation, we can conclude 0 is equal to minus RS IB minus HIE IB minus HRE, everything is equal to. So I am excluding this, so that minus of RS plus HIE into IB equal to HRE into VCE, and from this I can conclude IB is equal to minus HRE VCE by RS plus HIE. This is the IB equation, what I am getting in the form of H parameters of reverse voltage gain and the input resistance. And you consider this. Previously, already we defined the R naught, and this you consider it as equation 1. Substituting, just now I defined the IB value, substituting that IB in this equation. So here I am trying to write once again the R naught value. R naught is equal to VCE by HFE IB plus HRE VC. HFE IB plus HRE VCE. This is R naught. Now I have to substitute this IB value here. Then finally I am getting as R naught is equal to VCE by HRE VCE minus HFE HRE VCE by RS plus. This is the resultant equation of substituting IB in R naught. I am trying to substitute IB in R naught. This is the resultant equation what we are achieving. And from this we will have the little bit more simplification. In the numerator value I am taking VCE as common, already defined. The denominator also I am taking VCE as common. Then HRE minus HFE HRE by RS plus HIE. So that these two are cancelled. And finally, R naught is equal to 1 by HRE minus HFE HRE RS plus. So this is the final equation what we are achieving after defining the output impedance of an amplifier. So if you carefully observe all the parameters of this amplifier, everything is depending upon the H parameter. So finally what I want to conclude that without knowledge of H parameters, it is not possible to design any parameter of the amplifier, or if you not, it is not possible to analyze any parameter of the amplifier depending upon the condition. So with this I want to conclude here. So is there any doubts? Means a link is given in the description. For further details you ask, feel free to have the queries. Thank you.